Hello everybody. In this video or this lecture, I will be giving you an introduction of business analytics or data analytics, or how it all connects to business intelligence. So let me turn on my highlighter. Okay. So we are as we get into SAS Enterprise Miner or some other tool which you may use for doing business analytics. So the first question you might ask is that what is analytics, or what is business analytics, or what is business intelligence, and how are all these related to each other, as you can see on this slide. So let me give you a little bit overview. First of all these terms are quite related to each other. So there is a lot of overlap among them, and as the field has evolved and is still evolving, these terms, what do they mean, also are somewhat changing and evolving. So there's right now, if I say this is the definition of analytics and business analytics or business intelligence, it might change tomorrow. But the key understanding is how I understand the difference between these terms is, and we will, I have right here the definition as well. But just to get you started, you can think of analytics as, use of any analytical tool or any information systems tool, or operations research methodologies to sort of examine, investigate data. So that's that's a definition of analytics. Now, with business analytics, as the name implies, business, we are by having that word business analytics, we are simply adding to that analytics part a, a sort of a business focus to it, that now we are doing analytics for a certain business to solve a certain business problem. Then comes your business intelligence. The key thing about business intelligence is that business intelligence, there's a lot of emphasis on storing data, getting the data through a data warehouse, and then presenting, reporting on the data, querying on the data. So that's your sort of business intelligence. And as I said, I have right here, we will get more into it here and here as well. But just to give you a few definitions first. Now, if we look at analytics or business analytics, there are three kinds of analytics. Business analytics we do, and in this lecture I'll go over all these three: descriptive analytics, predictive analytics, and prescriptive analytics. What are these? Wait for 5 minutes and we'll get to that. Then the other term you will hear in this field is, are you a business or data analyst, or are you a data scientist? Or you can, what kind of work do you do? Are you a data scientist or a data analyst? Which means that, is your degree or education or training in the field of business analytics or data science? So there's a little bit a difference between these two terms as well. By taking this course, the course I'm teaching you, and the concepts which I'm teaching you the field of business analytics. That means you will become a data analyst, or you will work in the field of business analytics. Since most of you do have a background in business, or you are taking business oriented classes, especially when it's part of a MBA program, you are being trained as business analyst or a data analyst person. On the other hand, if you have a programming background, statistical background, or you are doing masters in data science, where you go quite in detail into statistics. With that, you combine your knowledge of Python or some other programming language, then you will be a data scientist. So you can think of data scientists as much more technical when it comes to using data. On the other hand, data analysts are much more business oriented in their use of data, or how they use the data. Okay. So right there. So there's this book which I really like. It's a new book which has come out pretty recently. It's called Business Analytics: Principles, Concepts, and Applications with SAS, What, Why, and How. So I've been reading that book recently, and this table comes from that book. So what this table does is it shows you some of the functions which are right here under characteristics, and how they are done under analytics, field of business analytics, and business intelligence. So as you can see, in the field of analytics, we are examining what is happening and what will be happening. Business analytics, what is happening now, what will be happening, which is same as analytics, and what's the best strategy to deal with it. And the reason for this is because we are now business, in part of the business, and the business, you want to provide a solution. This is the opportunity, or this is our prediction, how to take best advantage of it. On the other hand, the field of business intelligence mainly analyze or looks at past, what has already happened, and sort of try to examine it. All these three fields you use descriptive analytics. Predictive analytics is mainly used in business analytics field, not BI. Prescriptive analytics, again, not in BI. Three combinations, not in BI. Business focus is only in business analytics and BI. And focus on data storing, that's a very big part of BI through data warehouse. That's what we do, and you have seen in my presentation on data warehouse and on business intelligence that data warehouse is one of the key part of BI. So to sum it up, to provide you definition of all these three fields, analytics, process that use statistical techniques, information system software, which would be your data mining, sorting, routines, all those kind of things, and operation research methodologies like linear programming, optimization, to explore, visualize, discover, and communicate data, communicate patterns and trends in data. I'm going to then jump to business intelligence. Business intelligence is the field that converts data into understandable, meaningful information, with main focus on collecting the data, putting a structure on it, consolidating the data, then our ability to query the data based on our requirements, pull it out, and reporting onto the data. And reporting might include visualization. And now business analytics field combines both analytics and business intelligence. So business analytics include above, I mean analytics and BI, plus combinations of descriptive analytics, predictive analytics, and prescriptive analytics. And again, our goal is to support business decision making, because we are doing business analytics, we are not doing only analytics. So our goal is to solve business problems, to enable decision makers to take decision, and sort of produce implementable results, which business can use, which they can apply. Like, you want to make a prediction, this product sales would be this much in the coming holiday season, so that means increase the production, or some form of implementable results. Okay. Now let's get into business analytics. So business analytics is divided into three parts depending on its purpose. First is your descriptive analytics, which is when you do an analytics project, that's your starting point. What happened, what is happening. Predictive, as the name implies, what will happen. And prescriptive, you get a medicine prescribed, so as the name implies, what should we do for it. And these are the tools which fall under it. Let's go ahead and look into this one by one. So descriptive analytics is your first starting point when you start doing data analysis. And to make it a little bit more confusing, descriptive analytics can further be divided into three parts, which are pretty straightforward, nothing complicated. So what's the first part of descriptive analytics? Exploratory research. You get your sales data, your retail data for last 6 months. And your business people tell you our sales are declining. We don't know why. Here's the data set, figure it out. So right now the problem is very ambiguous. You don't know what is impacting sales, what is causing the sales to go down. So we don't even know how to define the question. We know our sales are going down. Why? What our hypothesis is. We don't know nothing. We are just exploring the data. So this first step, you will open the data. You will see what fields you have, on what field we have collected the data, what kind of customers data we have. You might make some charts, try to see is any data missing. You might want to explore, okay, what is the average age of our customers, how much money they spend, things like that. So you're simply trying to explore and understand the data. Once that step is done, then you move to the second step, which is descriptive research under descriptive analytics. So now you are sort of becoming aware of the problem. Since we have done exploration of our data, now we can start saying, okay, customers in this age group are buying our products, or our products is sold mainly on Saturday, Sundays, or our product sale is declining by 10% each month. So you are now able to define your problem much more clearly and try to see what is impacting, in this example, your sales. And then finally, the end of that is your casual research, where now you have a set hypothesis, where you say these variables are looks like these variables are causing decline in our sales. So these are the top 3, 4, or 5 variables which we think are important, which we should now use some sort of statistical analysis, data mining, or predictive analysis to understand more that what role these top variables are playing in our on our sales. Some of the tools which we use for descriptive analytics was, of course, charts. You try to create histograms, various line charts, and things like that to understand the problem. And I'll show you separately, or you might have seen under my visualization topic, various charts option available to us. Then you look at things like mean, mode, median, range, standard deviation. So you should have understanding of these simple descriptive analytics And that's always our starting point. It might sound simple, but that's our starting point of any complex data analysis. Let's look at the mean of all our fields which we have. What's the range of our field? What's the distribution? Things like that. So that's sort of our starting point of our data analysis. Once we are done, one more thing before we move to predictive analytics. We should have, you should have a basic understanding of difference between correlation and causation. As in a lot of analysis, data analysis, we sometimes confuse these two. Correlation is that these two variables are related to each other, and causation is let me change my pointer first. So there's variable x, there's variable y. So correlation says that these two variables are somehow related to each other. On the other, causation says that one variable is having a sort of a effect on another variable. So let me give you an example so that we can understand this better. If I do analysis and I say, every time Nitin Walia, which is I wear shorts, it gets sunny outside. So if I do analysis and my end result is that if Nitin Walia wears shorts and t-shirt, it's sunny outside. So that means that me wearing t-shirt and shorts is causing the temperature to rise or to be sunny outside. And if you do data analysis, you might be able to prove that, right? That there is an effect or there is a relationship among them. But yes, so there is a relationship among them because the relationship is that the reason I'm wearing shorts and the reason it's sunny outside is because it's summer. And in summer, when it's sunny and people do wear shorts. So these two variables are correlated with each other. They are not causing an effect on each other. So that's what we should be able to differentiate. Another example, the relationship between two variables x and y. One is temperature, another is ice cream sale. Yes, there it's a causation. The more the temperature goes up, the more is the sale of ice cream. So one variable is having a effect on another variable. So again, we should be able to differentiate. Like if I'm trying to see what effect certain variables have on sales, we should be able to see what variables are correlated with that sales variables and what variables are causing it. So okay, so we are done with descriptive analytics. Now talking about predictive analytics. In my other presentation on BI, I have talked quite a lot about this. Some of the data mining application in all these fields I covered in my introduction to my BI presentation, that how data mining is involved in banking, when you apply for credit card, mortgage loan, or your insurance company. That is, when you apply for auto insurance, how do they come up with your monthly premium, retailers for their sales and stuff, social media. So all these applications, I've already talked about this. So predictive analytics uses both statistics and data mining tools like machine learning, regression, decision trees, neural network, and we will cover some of these in this course as well. And the goal of predictive analytics is that you wanna develop a model to predict a future impact. by studying your past data. So if I wanna predict what would be my sales in future, I want to develop some sort of model where I say X1 and X2, which are some of my variables, they are impacting my sales in certain combination and stuff, which is what we will see in decision trees, neural networks, or regression. That's the purpose of our predictive analytics. The other thing I want to a little bit clarify is that since we are in the field of business analytics, we will be using statistics and data mining as a tool, tool which we apply to our business problem. So let's say in a statistics we get a result that it has a p-value less than 0.05, which means that this variable x3 has a significant effect on our sales. So we are looking at more as a tool to get our final result, final value. We are not that concerned about how statistics is being done, because that's what we are using our Enterprise Miner tool for. So we are letting Enterprise Miner do the statistical analysis for us, and we are using it in a much more applied way, unlike a data scientist who will have much more understanding of statistics and will play around a little bit more about the statistical part or methodology part. For us, it's a black box, it's a tool, and we simply apply it on our business problem. Our goal is more to get the data, have a business domain knowledge, then use a tool, Enterprise Miner, to do data mining on it, and then to sort of have the ability to understand the results and share it with our business people. I already have talked about quite in detail about supervised and unsupervised learning algorithms. So supervised are your regression, decision trees. Unsupervised is your association cluster analysis. Remember, we have talked about CRISP and CIMA as well. In SAS Enterprise Miner, we use CIMA methodology, which I'll show you in the introduction of business intelligence. Introduction of Enterprise Miner tool. Okay. So now, after we are done with descriptive analytics and predictive analytics, now we move to prescriptive analytics. So prescriptive analytics uses optimization, linear programming, simulation to make a recommendation as what should we do. So to tie it up, descriptive analytics we did to understand our data. Predictive analytics we did after we understood our data to make a prediction about our data in the future. So we made a prediction that these variables or this customer behavior is impacting our sales. Now, prescriptive analytics is the next step of this process, is that what should we do now for this prediction which we have made. So we made a prediction that these variables are impacting sales. So now how to have a positive impact on our sales, because we know these three variables impact our sales. So what should we do about it? How should we go about taking advantage of that prediction? And a very important part or very important thing to understand is that every firm, this is coming from organizational theory, that every firm has limited resources. Whether it's $1 billion firm or a small $100,000 company, it doesn't matter. Every firm has limited resources, and you want to allocate your resources optimally so that you get the most out of it. And that's sort of the goal of prescriptive analytics, is that based on this is a prediction. Now, based on this prediction, how should we use our resources to take the most advantage of this predictive analytics which we have done? So you can think of that all these three tools build upon each other. Descriptive, that's our starting point. Understand the data, made a prediction. Now, based on that prediction, what should we do? What should we do? And that's what we do. So what has happened? Descriptive analytics, what has happened? Predictive analytics, what could happen in the future? This, what have already happened in the past, what could happen in the future? And prescriptive, what should we do to take advantage of what we are predicting would happen in future based on our limited resources which our firm has. So that's how these three parts play together. And then some of the tools available under each of those things. Okay, so putting it all together, our first starting point, whatever kind of data analytics, business intelligence, whatever you do, our first starting point is data. You got to have data to be fed into any kind of analysis you can do. So that's our starting point. Data might be coming from data warehouse or a cloud storage. Most nowadays we are moving towards cloud storage. That's your feeder. Once you have your data cleaned, data in a structure, in a format, you first do descriptive analytics to sort of to have an understanding of data. Like, if I give you retail data, you have no idea what kind of data there is, what customer data there is, what kind of data I have on products, season, things like that. So that's what you start with. The results goes into predictive analytics. What's happening, why is it happening, and what will now happen in the future. Those results now are used for prescriptive analytics. Based on our prediction, what should we do? How to allocate resources of our company to take advantage of predictive opportunities which are coming from here. And that is sort of in a very nice, this is a very nice figure, shows you how a business analytics project is run. And if you remember from a last presentation, nearly 70% of 70 to 80% of business analytics project is getting the data, having a business domain knowledge, and cleaning the data. So basically, this part is what takes most of our time, and that's why having a business knowledge is so important. Then I have some examples of analytics or business intelligence tools. So this is coming from a paper, MISQ paper, which is like a top tier journal in the field of MIS. So there was this paper published in 2009, which talked about the role of business analytics in the presidential elections of that time, 2008, when Senator Obama and Senator McCain, they were the candidates, and then President Obama was elected. So President Obama, or at that time Senator Obama, campaign was responsible for bringing the field of data analytics to the way how campaigns are run, because they have limited resources, so limited money. So they sort of brought this field of business analytics to politics, to how elections are run, and now everybody does that. So and the key thing to understand is, again, not to focus too much on making some complex model or doing data analysis, but how you use it. So in their case, what they did was that, instead of saying that this person is Democrat and this person is Republican, so Senator Obama's team will only focus on somebody who is Democrat, which is how people were doing till that time. Last 50, 100 years, people will find the names of all the Democrats on a street, and if you're running a campaign for Democratic Party, you will go and knock on them and try to say, hey, vote for our guy in the primary election and things like that. But Senator Obama team approached the whole problem differently. They said, instead of marking people as Democrat or Republican, let's call them influenceable or lost cause or do not disturb. So do not disturb or lost cause meant that they have already made up their mind either to vote for Senator Obama or against him. So they have already made up their mind. We don't need to really spend our limited resources on somebody who cannot be changed or who cannot be influenced. So they said, let's not waste time on somebody who has already decided. So if they have already decided that we are going to vote for Senator Obama, you don't need to send them more flyers or information. Or if they have already decided they're going to vote for Senator McCain, again, why to waste your resources? So they said, let's try to go after people who are independent or still influenceable. Let's try to influence them, give them information to sort of attract them towards their side. And this is a very good example of how even you can apply this in a marketing campaign also. Like, for example, when Dish TV or DirecTV or AT&T TV sends a flyer out, they send it to everybody, waste of resources. So in a marketing campaign as well, you can see which people, if somebody is with DirecTV for a year or so, it's the likelihood of them changing their TV is their cable company is low. But on the other hand, if somebody who does not have cable, or maybe they have been with some company for more than 3-4 years, that means they are out of the contract, so maybe they can be now given a good incentive to change their cable company, something like that. Another example of business analytics, there was this analysis done on the credit card transactions, and the data mining tool said that people who use their credit card at drinking places like bar or stuff were considered more risky and were more likely to miss payments repeatedly. Same way, people who use their credit card at the dentist were considered quite safe and were less likely to miss payments. And people who bought this pads which goes under your chair legs or your table legs, so people who are buying this were considered that they are very, very credit worthy because they will never miss a payment or really miss a payment. Okay, so this is another example, and this is the best example of a difference between correlation and causation. So there was this study done on humans being attacked by shark, and they find out that if a human or a person eats ice cream, his or her likelihood of getting attacked by shark goes up very high. So what the study found was that if you eat ice cream, there's a very high likelihood that you will get attacked by shark. So again, we have to now see whether this is a causation. Eating ice cream causes shark to attack us, or maybe this is a correlation. And it is, if you think about it, it is a correlation, a relationship. Why? Generally, where are sharks? On the sea. And where do we can get in where can we have interaction with shark, or the common area on a beach? And what do we do in a beach on a summer day? You eat ice cream. So this so this was a sort of a correlation, because shark attack you on the beach, and beach it's hot, and there's more chances that of us eating ice cream at the beach. Is one of the most commonly done activities. So good example of something to be interpreted as correlation rather than causation. Another interesting example of business analytics, which is the interest rate of mortgages. So this study was done by Chase Bank, and when you get a mortgage, a home mortgage, or even an auto loan, if you do a prepayment, right? Let's say your loan was for 5 years and you paid back your loan in 2 years. So that means the bank will lose their income or the interest they would have earned from those other 3 years, because you paid back your loan early. So they don't want us to pay back our loan early. They want us to take our time, or at least the years for which the loan is applied for. So what they find out was, Chase Bank, that if the interest rate on a mortgage is it crosses 7.94, that means, let's say if it becomes 8%, then nearly 20% of customers will pay their loan early, which will result in loss of income for Chase. On the other hand, if the interest rate is lower than 7.94%, then only 4% of the people are likely to prepay their loan, which will mean more income for Chase Bank. So that's why so this tells us, or will tells the Chase management that try to keep the interest rate lower than this number. Another study which looked at the acquisition rate by when you get email offers and stuff. So people were Earthlink, SBC, or AOL, those kind of email ID were much more higher to reply back to a spam email than somebody who had Hotmail or Yahoo. Okay. So finally, my last slide. So this example has been mentioned multiple times in many analytics conference I have attended. Whether it's true or not, I don't know, but it's like an urban myth, and this myth gets repeated at every conference I go to. And what that myth is, that there was this study done by in UK of retailing data of a company similar to Walmart, and they found out that young men under 34 on Saturday afternoon, when they will come to superstore like Walmart, they will buy beer and diapers together. So these two items were sort of correlated with each other for sales on Saturday afternoon. And so, which is a little puzzling, that why would people buy beer and diapers together? And they sort of looked at the data, and they find out that young men are buying. So they said, why is beer and diaper always being sold together on weekends? So then they looked at the data more carefully, and they find out that young men are buying these two items together. And if you think about it, young men under 34, let's say, they are more likely to have young kids or infants or kids who wear diapers. And if you have kids who wear diapers, you cannot go out to a club or a bar on Saturday. You will be at home taking care of your child. But it's still Saturday. You want to relax. You want to have maybe a drink or so. But you cannot have scotch or vodka or rum. You don't want to have such a strong drink and get pass out while you're taking care of your child. So you will end up having something as like wine or beer on Saturday while you are at home taking care of your child. So that's sort of the reasoning why these two items go together on a weekend. Okay, so that sort of was my introduction to to the field of business analytics. I hope you enjoy the lecture. Take care, and if you do decide to drink beer, drink carefully.